Hello, Internet. So it occurred to me I haven't really shown a good gravity simulation or a light simulation uh, from this equation yet. So here is the unified theory of everything simulation running the equation energy over space. And a lot of people want me to explain all the secrets of it. I get it. I'm putting together a website to explain all the secrets. I planned on doing this through Patreon. Patreon isn't going to work out. It's turning out to be a terrible platform for this. The strategy plan all along had been to have my own website where I would release this information. So I'm just going to go forward with that, and that should take maybe about a month from now. I'll have a website up. Or here's an alternative. If anybody knows Joe Rogan or a podcaster that can get I'd say at least 10,000 views, I will release the secret live on the air. Okay, I'll also explain ahead of time to the host and somebody else, like an associate or whoever. I'll explain the entire thing ahead of time to that person, just so they know this is legit and I'm not going to be clowning them on the air. So yeah, I'll explain it live on air how everything works. I could talk for a long time. It will be very exciting. It will be exciting. If you've seen the video, you know it's 2.5 hours long. Like, I could talk much longer than 2.5 hours. I could just go on and on and on. So it will be exciting. It will be engaging. It will be fun. If anybody knows anybody, let me know. Okay, message me. The ideal would be Joe Rogan, but let's see who you got. All right. So, all right, on top here, the way this equation works. On top has to be, well, it has to work in parallel. It just has to work that way. So these are time steps removed from each other. So you think of this like 1 second, 2 seconds, 3, 4, 5, 6, 7, 8, 9. See how it goes? It goes back and forth. It's like ping ponging back and forth. It has to work this way. I'll explain live on the air why it has to work that way. Unified physics. Imagine the podcast that could say, we broke unified physics. Like, we broke the news. We broke the news about how the universe works. Imagine how great that podcast would be. Okay. So let's see if anyone can make it happen. It's legit. This is legit. All right, so I'm going to be showing gravity and then also electromagnetism, like light. So I've showed before how we've got the photons and electrons and all that, but you haven't actually seen it like in the way that you have seen like the slow-mo guys new video. So have you seen the video where it's very recently, the slow-mo guys, they filmed light at like 1 trillion frames a second. Yeah, we can reproduce that. It looks just like it. And I made my simulation before they released that. So it's not like I'm trying to copy the slow-mo guys. It's like I made my simulation and then the slow-mo guys made their video, and what do you know? It looks just like my simulation because my simulation's legit, fam. Okay, so you're going to notice this looks a little different from before. That's because I have different color filters on it. It's the same simulation, same thing, energy over space, same exact thing. It just has different filters over it. This one's filtered, and if you think I'm just making this up, if you'd watched the 2.5 hour video, which is time-stamped, so I didn't revise the video. It's time-stamped. If you'd watched it, and I've got friends who have watched it. Some of my friends have watched it. There's people I trust in my personal life. They know this stuff. I've explained everything to some people in my personal life. I'm not the only guy. So some people who I know personally, they know this stuff. They've seen the video. They know that this has been around for months now. Longer than months. Maybe it's been around a few months. Yeah. I'd have to check on the actual date where I actually finished this. But anyway, so this is gravity on top. And then I'm going to show you electromagnetic wave propagation. So this is starting from a Big Bang state. So it starts very disorganized and it optimizes over time. You're gonna notice that everything gets pulled together. It gets pulled between red and blue. And it's because red is high. It's high. It's positive energy pressure, and blue is negative energy pressure. And this, you're like, how can a number be negative in the real universe? Doesn't everything start at an absolute scale? Isn't everything absolute? And the answer is no. If you watch Veritasium, go watch the Veritasium video, negative pressure in fluid. They have Veritasium is a great program, by the way. I have mad respect for the Veritasium team. And they have a great video on there called it's How Does a Tree Work? And it's going to show you how negative pressure in the liquid is how a tree works. So negative pressure actually is a thing. It's not an absolute scale with liquid. It goes into negatives. And also Thunderfoot has a great video too. Go check out Thunderfoot. Thunderfoot is an awesome guy. And he's got a great video showing negative pressure in fluid. So negative pressure is real. It's not woo-woo. So blue is negative energy pressure. Red is positive negative energy pressure. And they're convertible. They can convert into each other. However, they kind of tend to stay to themselves. Red attracts red, blue attracts blue, and they tend to repulse the opposite. So the fundamental force is positive and negative. So what's going on here is it's only showing the top 10% energy pressure of red and lowest 10% energy pressure of blue. So this is the exact same thing as before. It's just using a different color code. So now everything's being hidden except for the top 10% and the lowest 10%. That's what's going on here. Now watch how they attract. That's gravity. This is gravity working on extremely small scales. This is quantum gravity you're looking at right now. Now, you're like, but it's so mushy. They're like little blobs, and when planets attract each other, it's like they maintain their integrity, right? They're still spheres. They don't go like little squids, like little balls of mush. Okay, so we're looking at a Planck scale. This is a Planck scale simulation. Like, it's mushy at this scale, all right? And as we get more and more mass, it maintains its integrity a lot better. What is gravity? Gravity is a system of averages. Gravity is averaging towards, it's an average. It's a system of averages. Like, I'm not just saying this. Think about it. Think about it very logically here. Okay, so imagine this is the sun, or no, better yet, think of these are two planets of equal mass. Okay, think of this on a number scale. Okay, imagine this is at -10 on a number scale. This is at 10. Okay, now what's the average? The average of these two is at 0. That's what gravity is. It's an averaging. Okay, then you might be like, well, but they spin together, Gary. They spin. They don't just go like this. Yeah, you know why they spin? Because they're averaging towards the past. That's why. Gravity takes time to propagate. So it's moving, and then this is averaging towards where it was, not to where it currently is. Holy cow, Gary, you actually did it. No kidding. That's what I've been saying this entire time. This isn't a scam, guys and girls. This isn't a scam. I really did it. Okay. So they're attracting. You're looking at quantum gravity right now. That's what you're looking at. This is quantum gravity. But it happens so slowly, Gary. Yeah, no kidding. Gravity is the weakest force. You should know that. Takes a very long time. Every time I click this mouse, it's progressing like one time. Each time step is very fast. Like, you can think of it in terms of speed of light. So it's in terms of speed of light. How much faster is light than the speed at which Earth rotates the sun? Well, it's a lot faster. It's like, I don't remember what the calculation is exactly, but it's like light is 10,000 times faster than the speed of Earth rotating the sun. It's something like that, and it's very fast. It's not as big a number as you might think, if I remember. I'd have to check my actual calculations, but the number is not, the speed at which light moves is not as fast as you might think compared to the speed of that gravity is pulling Earth around the sun. It's something like 10,000 times faster though. So yeah. So if I remember the calculations correctly. So yeah. So gravity is very slow in this simulation. It's slow. And it's more noticeable the more mass there is. Because what happens at this scale, particles tend to decay very quickly. So you're going to notice that. So like over here, this particle is decaying before it can even noticeably get attracted to another particle. See over here? Now we can see these the gravitational. It's like, it almost looks like a kind of like a force field sucking it in. So they're getting attracted to each other. It's almost like a little force field. What's actually happening, they're finding an average towards each other. Why aren't they rotating, Gary? Because this scale is so small. To get to a scale where things are actually going to start attracting towards the past and rotating, we need to scale up the simulation to supercomputer scale. Like, we need billions of cells to do something like that. That's why I need to raise money so we can get the time, we can reserve the time on a supercomputer to do this kind of thing. We need to be running this on a supercomputer. Furthermore, I want to be running this in 3 dimensions. So I have a patent pending on a 3-dimensional spreadsheet. Microsoft, holla at me. Wolfram, holla at me. I got the patent pending on it. That's a great idea, Gary. Yeah, no kidding. I'm a pretty smart guy. Who would have thought the guy who unified physics is a pretty smart guy, huh? 3-dimensional spreadsheet. Got the patent pending on it. See down here how this is going to get sucked into that one? But it's also getting attracted to this one, see? See how this one's caught in between the attraction of these two? Y'all thought this was a scam. It's not a scam, y'all. I did it. I really did it. Okay, I'm going to stop this and then I'm going to show you light propagation. Alright, so here's light propagation. And you're going to see it propagate. And if you watch the slow-mo guys, they had a video recently where they filmed light at 1 trillion frames a second. And it looks just like this. And basically what I've done is I've entered the equivalent of a supernova into the equation. So you see how they're connected? These are the same thing. Every single video I've shown, they all, you might think they all look a little different, but that's just because there's different filters over them. The data underneath is always the same. It's always the same. The data here on top, I don't think you can see my mouse, but the data on top is the same as the data below. They're just one time step removed. And so they just have different filters so you can see different aspects of them. So for example, the filter you're seeing right now is the energy pressure that is in the middle 1%. So I want to think of it like 49.5, you know, on top and bottom, or however you want to think about it. And it's very slow. It propagates very slowly because each click is like light speed. Each click is how fast it takes light to travel one of those little cells. So it's very slow. So to see real movement, I'd have to click this many times, many times. And up here you can see that it is being, it's pushing the negative energy pressure away. You see that? It's pushing the negative energy pressure away from it. So the fundamental particle force is attraction and repulsion. And in the optimum theory video, I also show how those two forces, attraction and repulsion, how they optimize into complex and organized systems, some of which have shown to reproduce themselves. And that's, therefore, abiogenesis. Yeah, it would take me a really long time. Just click, 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 click. But watch the slow-mo, guys, and you'll see this what light really looks like. And I did not even know that at the time. I made this simulation, and it's time-stamped. I have video. You might not have seen me create these light propagation videos, but I have time-stamped video. It's been done for a while, and my friends have seen it. My friends have seen this stuff. You know, in my personal life, they know what I'm working on. They know all about it. I'm not like keeping the secret from them. And they've seen it, and so I saw light before the world saw light. So in that slow-mo video, slow-mo guys, they're 1 trillion frames a second. In that video, it was like from last week they released it. The whole world saw what light looks like. But I saw that, I've seen that. I saw it months ago. So when people talk about how my simulation isn't falsifiable, that's not true. I saw light before they saw light. I modeled light, and then the world saw it. The world got to see what I saw. Anyway, like I said, get me on a podcast. I'll show the whole world the simulation. All right, talk to you later. Bye.